Hi, this is John, and welcome to another edition of Statistics Tell a Story. So I wanted to follow up on something I did a few days ago with Dan Campbell and his onside kick, and it occurred to me that I assumed 5 drives, which actually would give the Bills one more possession, which would suggest more strongly that Campbell should do an onside kick, meaning my numbers might have been a little bit biased in favor of Campbell doing an onside kick. So in fairness, you have to think, well, can we think of a distribution of a reasonable number of drives? Ironically, last week, I believe I heard in the Steelers-Eagles game, the Eagles set a record for the most number of plays to end the game without scoring. I think it was 21 plays. They ran off like 9 minutes a time. Well, there were 12 minutes left in this game, so there's probably not going to be just one possession, okay? And there's probably not going to be 2 possessions. I mean, there could be, but especially with the Lions needing to hurry, that, as far as scoring goes, there probably won't be 2 possessions. So at what point do you think there might be a reasonable number for possessions? Of course, if there's 1 or 2 possessions, the Lions can't win anyway, right? Because they need to, if there's 2 possessions and the Bills have 1 of them, they can't possibly win. So we might reasonably start at 3 possessions, okay? And then go from there. So you might have 3 possession. When I say possession and drive, is basically, I'm using interchangeably. So you might have 3 possessions, 4 possessions, etc. This kind of takes on what we might call a Poisson distribution. I'm not going to get into the weeds with what a Poisson distribution is. I'll just say that typically a Poisson distribution is skewed heavy towards 0s and 1s and 2s, and then it tails off. So for example, the number of telephone calls a switchboard operator might get in an hour. It might be 0, depends upon how much traffic that is. Might be 1, might be 2, etc. It might look something like this. If it's prone to getting a lot of calls, depending upon where it is, right? If it's on a Saturday and you don't get many calls, there's a good chance you might get a 0. Or, you might not have such a good chance of 0, and then as you get up to maybe 2 or 3 or 4 calls, it peaks, and then it goes down from there. So I think we have a similar type of thing going on here. I took some educated guesses, okay? Which I'll get to in a second. So it does benefit the Lions to have an even number of drives. Remember from my first podcast, we assumed a few things. We're taking some liberties just to make some calculations easier. We're assuming no turnovers, we're assuming no field goals, and we were assuming all things being equal, there's a 50% chance that a team scores a touchdown. And the reason we had increased that number from what might be given norms is we're in the 4th quarter, a lot of injuries at this point, etc. So we might say, okay, how many drives might we get? 1 is extremely rare, right? And again, it really wouldn't matter in this case as far as what the Lions did, because the Bills would run out the clock, the Bills win. 2, I think, is pretty rare. And again, the Bills would win. 3 is maybe not so rare. Even in that game, I checked, there were, I believe, 3 drives of more than 5 minutes. So very realistically, the Bills could get the ball, keep it 5.5 minutes. Lions, whether they score or not, let's just say they don't score. The Lions maybe score in 3.5 minutes or 3 minutes. At that point, they might have to onside kick, but the Bills might run out the clock. Okay, so I'm going to put a sweet spot at 3, 4, 5, and 6 drives, okay, and with the sweetest of these sweet spots being 5 drives, okay, and again, this is just kind of a gut feel. I don't know if it's right or wrong, but I'm going to say 40% of the time there's 5 drives, 27.5% of the time there's 3 or 4 drives. I think when you get beyond 5 drives, it gets pretty rare, especially with, the Bills not in a hurry to score. Obviously, the Lions are in a hurry to score. I'm going to put it at 5%. Again, 1, 2, and then 7 and beyond, I think, are very rare. But we're not going to get that granular, so we're going to stick with this. So assuming these numbers, with the same assumptions I had before. Now, what can happen? So you have drives, 3, 4, 5, or 6. The number of drives we just said, 27.5, 27.5, 40, and 5. How often do the Lions win, either kicking off or onside? Well, if there's 3 drives and they kick off, they can't win. Why can't they win? Because the Bills are going to have the ball twice. The Lions are only going to have the ball once. They can't possibly win. If they do onside, they could win. And again, I'm not going to show all these numbers, but very similar to what I did before, looking at scenarios. If you'd like to know, you can put it in the chat, or you can maybe do it yourself and check these numbers. But if they do onside kick, they can win, even if there's 3 drives, because they get the ball, they score, Bills don't get the ball, then the Lions, with their third possession total, they score. Very rare, almost 1%. Okay, 4 drives. Now, 4 drives, it actually suggests the Lions should kick off. Why? Because they're getting 2 drives to the Bills' 2 drives. Kicking off actually is pretty simple. If they kick off, you need the Bills to not score, Lions to score, Bills to not score, Lions to score. That's real easy. This is probably the simplest of any of these. It's actually 1/2 to the 4th power, which is 0.063. If they do onside, again, going through the numbers, very similar to what I did before, not quite as good as the 0.063. This is exactly what I did last time. And you might recall if they kicked off, it was 0.031. I suggested Campbell was slightly right, at least with assuming 5 drives, 0.033. If there are 6 drives, it's a little better to kick off as opposed to onside. Well, we put that together. This becomes, in essence, what's called a sum product. So if they kick off, 0.275 times 0 plus 0.275 times 0.063, etc., we get, voila, 3.5%. By going onside, doing the same thing, we actually get the same number we got before. This is coincidental. It's 3.3%. So trying to be as fair as possible, this actually suggests Campbell was slightly wrong to do onside. Remember my original premise all along was I thought it was a very close call. Interestingly, I did not look at, there is a football calculator that gives probabilities depending upon down, distance, etc., score of the game, how much time's left. And I looked, and it was actually about 3.5%. So my numbers are, I think, pretty reasonable. If you look, I think it might be on Football Reference if you want to ever check that out. So that's kind of a neat little tool. You can check probabilities and so forth. And they've done that. Analysts like Brian Burke and others you may have seen in some sports articles will use that as a reference to determine whether or not teams should punt or maybe kick a field goal or whatever in certain situations. It leads to something called game-winning probabilities. Anyway, so, I don't want to spend too much time on the weeds on all these boring numbers, but anyway, crunching the numbers, this slightly suggests that Campbell should have kicked off, but again, we're making certain assumptions that, might veer a little bit one way or another. Anyway, glad you tuned in once again for Statistics Tell a Story. I actually will have my Week 16 picks up later today, but for now, I just have this. I'm going to sign off, and I'll see you next time on Statistics Tell a Story. Thank you.